Hello everyone. In this video we are going to talk about solving linear systems using matrices. So this far, right, we've worked with moving linear systems into echelon form, but with a lot of variables running around, it can be a lot of writing. And so one of the nice things that we can do is that we can translate a linear system into matrix form. So we're going to consider the two following linear systems. So first we're going to take a look at number one, as you might imagine. So I'm going to underline here. So, right, these are secretly like a 1, a -1, a 3 here. So we have what's called the coefficient matrix, and it's exactly what it sounds like. You pluck the coefficients from your linear system, right? So here we have two equations, two variables. This is going to be 2 by 2, and it's just simply 2, 3, 1, 1. And then, of course, we care about the equals 5 and equals 0 as well, right? We literally have equations here. And so then we can make the augmented matrix, which just adds that column, but we also designate that these are different, that these are past the equal sign by putting this bar, this vertical bar in before the final column, okay? So then for this second one, right, so this first row for our coefficient matrix, well, we only have a 3 in the third spot. This is going to be a 3 by 3 matrix. We have 3 variables and 3 equations. 1, 5, -2, 1/3, 2, and 0. And then our augmented matrix is going to be the same thing, except for we add this final column with what's coming after the equal signs. Okay? So we will primarily be working with the augmented matrix, and we'll be putting it in row echelon form, just as we were putting the linear systems themselves in echelon form. But now we don't have to write quite as much, and it makes our computations a bit quicker. So I want to do one more example because the previous two led to kind of square coefficient matrices. So our coefficient matrix here is actually going to have two rows because we have 2 equations, and then 4 columns for 4 variables. Okay, so this is going to be 1, 3. We have 0 before x3, 1 before x4. We have no x1 term, 1, 0, and then -2 before x4. Right, and again, the augmented is going to be the same thing. And then we just tack on this last column with what is past the equal sign, so 1 and 1. All right, so in general, right, if you have m equations, this corresponds to m rows, and in variables corresponds to in columns. And this is in the coefficient matrix, not the augmented. You'll have an extra column in that case. Okay, and so now that we've done some examples, I want you to do this for your first exercise. Just write the following 2 linear systems in their augmented matrix form. So now we're going to start working towards putting these augmented matrices in row echelon form so that we can solve these linear systems just as we were without matrices. And so we have the associated elementary row operations that we're allowed to do. Okay, so these are the same row operations that we are performing on linear systems. We just call them elementary row operations for matrices. They are exchanging 2 rows, multiplying any row by, again, it's very important, a non-zero constant, or adding a multiple of 1 row to another row. And all 3 of these things will, of course, change your linear system, but will keep the solution set the same. Okay, so first let's just recall what row echelon form means, and it's the same thing for augmented matrices as it is for linear systems. So first, the first non-zero entry in each row, which we call a pivot or the leading coefficient, is to the right of the pivot of the row above, and all rows with only zeros are at the bottom. Okay, so our goal is to work with that. So let's go through some examples. All right, so we're going to go back to the 2 systems we started with. So we had 2, 3, 5, 1, -1, 0. And our goal is to get this in echelon form. So, we could introduce fractions here, but I kind of like seeing this 1 and want to make that a pivot. So I'm going to start by doing a type 1 row operation and exchange two rows. Right, and so then we're going to have 1, -1, 0, 2, 3, 5. And now I can subtract 2 times row 1 from row 2, right, and get rid of everything below, right? So once we have our pivot, we want to clear below it so that the next pivot is to the right. And so we keep the same first row. This is going to become a 0. 3 plus 2 is going to be 5, and 5 minus 0 is 5. Easy enough. And this is enough for us, right? So we can now translate into this new system. So we have x1 minus x2 is 0, and 5x2 is 5. So clearly, x2 is going to be 1. We can kind of back substitute here. And then x1 minus 1 is 0. So x1 is also 1. And so we get the solution 1, 1. And you may also see solutions written, and we'll start doing this more and more now that we have matrices written in column vector form. And so the solution could be written 1, 1, where this is the x1 row and this is the x2 row. Okay. So now let's look at the second system that we had. So this is very clearly like not in echelon form right now, right? We like seeing this 1 here. This is going to be a pivot. Right, because our first row has its pivot to the right of something below, that's bad. So we want to do some switching. So I would start by switching the first 2. So we'll get something that looks like this. And from here, right, we want to clear below this pivot in the top left. So we want to clear this 1/3 out. Now you have a couple of options here, right? Solving these is not going to be done uniquely. So you could subtract 1/3 of row 1, but I don't really like introducing a whole bunch of fractions. So I'm just going to multiply this whole guy by 3 and get rid of that so it has 1 instead of 1/3. Okay. And so now we have this, and we can clear this quite easily, right? So now we just subtract row 1 from row 3, and we will get. All right, so now we've cleared out that first column below, and so then we're looking for our next pivot, right? And again, this is to the right of this, so really this is our next pivot, this one down here. And so again, we would like to switch the second and third row so that we can get this in echelon form. And this is what we end up with. And now we actually have all of our pivots in nice order, and we are in echelon form. And now we can just do that back substitution, right? We have this nice kind of triangular thing going on. So we have 3x3 is 9. So x3 is 3. And then we have x2 plus 2 times x3, which is 3, equals 7. Well, that's 6, so that means x2 is 1. And then finally, x1 plus 5 times 1 is 5, minus 2 times 3, so plus 5 minus 6 equals 2, and so we just add the 1 over, and x1 is going to be 3. And so our final solution, I'm going to write it in column vector form, is going to be 3, 1, 3. And so this is a consistent system with one unique solution. And to close out, we have the second exercise here. So this is a 4x4 linear system. So I want you to first write the augmented matrix down, then put it in row echelon form. You know, it'll be a few steps, and I want you to tell me what operations you're using to get from step to step so that I can keep track of what you're doing, and then use the row echelon form to solve the system. Thank you for watching.